Hello students, good morning. Today I am going to explain hydrocarbons. The hydrocarbons alkane, alkene, alkyne, benzene. Continuously one by one we'll discuss. Okay, so I will try to complete four topics. These four topics within 2 weeks. Later I will explain the general organic chemistry, nomenclature, electron displacements. Okay, so what are the basic organic concepts required for the second year organic? Okay, those topics also I will explain. Okay, hydrocarbons. Okay, hydrocarbons. Hydrocarbons, the name only it is there. The definition of hydrocarbons is the organic compound containing carbon or hydrogen is called hydrocarbon. The organic compound containing carbon or hydrogen is called hydrocarbon. Okay, carbon and hydrogen containing compounds are called hydrocarbons. Okay, so these hydrocarbons again classified into different types. Okay, hydrocarbons are again classified into different types. Okay, so in these hydrocarbons, first mainly two types are there: open chain hydrocarbons, and here closed chain hydrocarbons. Okay, open chain and closed chain. Open and closed chain. This closed chain is also called as a cyclic compounds. Okay, these open chain compounds again two types. Open chain compounds again two types. Okay, so carbon single bond containing compounds. Open chain compounds again two types: carbon single bond containing compounds and carbon double bond, carbon triple bond containing compounds. Simply these are saturated and these are unsaturated. Okay, so saturated and unsaturated. Carbon single bond containing compounds, saturated. Carbon multiple bond containing compounds, unsaturated compounds. Examples for the saturated are alkanes. Okay, alkanes. General formula CN H2N plus 2. Here double bond means alkenes. Formula CN H2N. Alkenes. Next triple bond means alkynes, CN H2N minus 2. These are alkynes. Okay, so in this way open chain compounds can be classified into saturated and unsaturated. Saturated compounds means carbon single bond containing compound. Unsaturated means carbon double bond, carbon triple bond containing compounds are unsaturated. Okay, next closed are cyclic chain compounds. These also again divided into two types. Okay, these are alicyclic compounds and aromatic compounds. Okay, alicyclic compounds, aromatic compounds. Alicyclic means single bond. Okay, are your alicyclic means cyclopropane, cyclobutane, okay, cyclopentane, okay, cyclohexane, okay, cyclopentene, okay, these are alicyclic. Next aromatic compounds. Aromatic compounds means benzene, naphthalene, anthracene. Anthracene means 3 benzene is fused. Okay, so in this way, benzene, naphthalene, anthracene, these are aromatic compounds. This is the classification of hydrocarbons. Okay, now we are going to discuss very first one, saturated hydrocarbons, that is alkanes. Okay, so alkanes contain carbon single bonds. Alkanes contain carbon single bonds, so they are called saturated compounds. Okay, they are called saturated compounds. Next, here these alkanes. Next, here alkanes they are also called as paraffins. Okay, para means little. In Latin language, para means little. Okay, affins means reactivity. Affins means reactivity or affinity. Okay, so why they are called paraffins? Because why they are called paraffins? Because para means little, affins means reactivity. So alkanes are less reactive. Simply less reactive. Okay, alkanes are simply less reactive compounds. Okay, next in alkanes, carbon-carbon single bond is formed by the sp3 overlapping. Okay, and bond length is 1.54 angstrom units. Okay, carbon hydrogen bond. If this is sp3, the alkane carbon means alkane carbon. This is sp3 carbon, and this CH bond. In alkane, CH bond is formed by which overlapping sp3 s overlapping, and bond length is 1.10 angstrom units. Okay. So this is sp3 overlapping. This is sp3 and s overlapping. Okay. So in this way, those two bonds are formed. Next, here sp3 means what is a geometry? What is geometry? Tetrahedral. What is the geometry? Tetrahedral. And bond angle. Bond angle is 109 degrees 28 minutes, or 109.5 also, 5 degrees also you can write. Next, alkanes nomenclature. Alkanes nomenclature. Okay, so alkane structure ABSE name. Okay, so if you take first one CH4, okay, which was structure CH4 only, it's ABSE name. One carbon, so meth. One carbon root word meth, single bond, so methane. Similarly, next if you take the second one now, C2H6. C2H6. Here CH3. Okay, two carbons, so eth, single bonds, N. Next C3H8. CH3, CH2, CH3. Three carbons are there, so pro. All are single bonds, so N, propane. Okay, next C4H10. C4H10 means we can write CH3, CH2, CH2, CH3. Okay, this is one N-butane. And next, okay, so how you can write this compound name over here? This is the longest chain. Okay, you have to give numbering 1, 2, 3, and this is the substituent. This is the substituent attached to the second position. So 2-methyl, 2-methyl. Three carbons are there in the longest chain, so prop. All are single bonds, so N, propane. So 2-methyl propane. Next, take C5H10. Okay, here CH3, CH2, 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 CH3. This is N-pentane. Okay, one more will get CH3, CH3. Okay, CH2, CH3. This is isopentane. Its common name is here. This one is the longest chain. Here, this one is the longest chain. Okay, if you give a number 1, 2, 3, 4. Okay, 1, 2, 3, 4. At second position, methyl group is there. So 2-methyl, and in the longest chain 4 carbons. So it is a butane. 2-methyl butane will come. Next, one more also we can write CH3, CH3, and also CH3. Okay, so this is isopentane, this is a new pentane. Okay, so new pentane, based on what here, this only longest chain. These two will become substituents. So at which position there are substituents at second position? Substituents at second position. So second position means 2 you can write. How many 2 substituents are there? So 2, 2. Both are same. Okay, so that's why 2, 2 written. to come to dimethyl. Okay, to come to dimethyl. To come to dimethyl. So in the longest chain, 3 carbons are there. So prove A. So to come up to dimethyl propane. This is about the nomenclature of the alkane. Here, butane can for butane I written two. These two are which one? Chain isomers. Okay, these two are chain isomers. For pentane, how many I written? For pentane, I written 3. So here these are also chain isomers. Okay, chain isomers. Okay, if you see the structural isomers for alkane, CH4, C2H6, C3H8. These three most structural isomers. Okay, next C4H10, 2, C5H12, 3, C6H14, 5, okay, C7H16, 9, okay, C8H18, okay, here 18, C9H20, 35, C10H22, here 75. Okay, so for all these alkanes up to decane, these many chain isomers are possible. Okay, this is about structural isomerism and the nomenclature of the alkanes. Alkanes nomenclature clearly we'll discuss again in one more topic, nomenclature. We'll take the GOC that I'll explain. Okay.